A construction site is a very busy place. Many people are doing work. This kind of work is the moving of something from one place to another. This backhoe does work by moving dirt. This crane does work by lifting things. Work requires force. Force is the pushing or pulling of something. Many different kinds of machines help people do all this work. A machine is anything that helps people do work. A playground looks very different from a construction site, but these students are also doing work. They are doing work because they too are moving things from one place to another. The playground also has machines that help people move things. This slide is a machine.
It takes me from the top of the slide to the bottom.
The wheels on these roller blades are machines. They help this girl skate from one place to another. Machines like the slide and the wheels on the roller blades are called simple machines because they have few, if any, moving parts. Many of the machines on the construction site are not simple machines because they have many moving parts. But understanding how simple machines work helps us understand how complicated machines work as well. All machines, even the most complicated, are made up of 6 kinds of simple machines. These simple machines are the inclined plane, the wheel and axle, the pulley, the screw, the wedge, and the lever. Try lifting a classmate or an older brother or sister. It can take a lot of force. You might be able to lift her a little, but it's not easy. Now, try doing the lifting with the help of a seesaw. It takes less effort. The seesaw is a simple machine called a lever. All levers have the same parts. One part is a beam, a rod, or a stick. This part is often called the lever stick. The lever stick rests and turns on another part called the fulcrum. Whatever is being moved by the push or pull of a force is called the load. Here, one student is the load, and the other provides the force. You can make a lever with a ruler and 3 pencils taped together. The fulcrum here is the pencils, and the lever stick is the ruler. If the fulcrum is in the middle of the ruler, and you put the same kind of block at each end, they balance each other like this. Now put 2 blocks on one end, and move the fulcrum so that it is close to the end with the 2 blocks. Most of the lever stick is now on the other side of the fulcrum. See if you can lift the 2 blocks using just 1 block. If you put the block close to the fulcrum, it doesn't have enough force to move the other blocks. But look what happens when you move the block farther away. The greater the distance of force is from a fulcrum, the less effort it takes to move a load, like these 2 blocks. Lots of tools are based on levers. This is Hillary Hamilton. She is a carpenter.
I use a lot of different tools, and they're all based on simple machines. This hammer is an example of a lever. I can use it both to drive the nail in or pull the nail out. And there's a fulcrum right about here on my hammer, which enables me to have enough power to pull the nail back out. This is a screwdriver, which can also be used as a lever. You can use it to open the paint can with the fulcrum point right at the edge of the can.
Your kitchen probably has levers in it. This nutcracker is a lever. It helps crack a nut. This bottle opener is a lever. It can open a bottle. Here is a problem for you to try to solve. How can this girl move this large rock? If she tries pushing it, she can't even make it budge. But nearby there are two things that might be able to help her. There is this log and this board. What would you do if you were the girl? Your teacher can stop the video here for you to answer this question. Otherwise, the program will resume in 10 seconds. How can the girl move the rock? She can use the log and the board as a lever. The log works as a fulcrum, and the board works as a lever stick. If she pushes down on the board, she can move the rock. This man is doing some heavy lifting. But this box is too heavy for him. Is there an easier way to get the box into the truck? He could use a board to slide the box up. When the board is used this way, it is called an inclined plane. An inclined plane is a flat surface with one end higher than the other. Inclined planes make it possible to move something from a lower place to a higher place with less effort. You can see inclined planes in many places. This road is an inclined plane that helps the truck get to the top of the hill. A slide is an inclined plane. If this student jumped from the top of the slide, he would fall straight down with a lot of force and might hurt himself. But if he goes down the slide, he reaches the ground by moving more slowly over a greater distance, and he lands with much less force. Here is a wooden block and two ramps, or inclined planes, that go up to the same height. One inclined plane is longer than the other. Do you think it will take less force to pull the block up the shorter inclined plane or the longer one? This student uses a rubber band to find out.
I hooked a rubber band to one side of the block. Then I pulled the block up the shorter ramp. The rubber band stretched a long way. Then I took the block and pulled it up the longer ramp. I had to pull it further, but it was easier to pull, and the rubber band didn't stretch as far.
How far the rubber band stretches is one way of telling how much force it takes to move the block up each inclined plane. If the student lifts the block straight up without the help of any inclined plane, the rubber band will stretch the most of all. Here are two inclined planes. Put them together, and you've created another kind of simple machine, a wedge. A wedge helps people do work by making it easier to push things apart. This axe is a wedge. It pushes wood apart. Carpenters like Hilary Hamilton use many kinds of wedges.
This is a chisel which acts as a wedge. It has a very sharp edge on it, and I'm using it to remove some of the wood at the edge of this door to place a hinge here.
The point of this nail is another example of a wedge. It makes it easier to hammer the nail into the wood. Can you think of any other wedges?
The edge of a knife.
What about this boat? Can you see a wedge anywhere? How about the bow, the pointed front of the boat? By pushing the water apart, the bow makes it easier for the boat to move through the water. Cut a piece of paper in the shape of an inclined plane. Then, wrap the piece of paper around a pencil. What does it look like?
A screw.
A screw is an inclined plane wrapped around a post. Screws are useful in many ways. They hold things together. Here, a screw is being used to hold a hinge to a door. The cap of this bottle is a screw top. Screws can also be used to move or lift things. Do you think this woman can lift this car? With the help of a screw, she can. This jack has a kind of screw. By turning the handle, she turns the screw, and the screw lifts the car. Tie a string around a book and hook a rubber band through the string like this. Pull the book across the top of a table. The rubber band stretches a lot because the book rubs against the top of the table. This rubbing is called friction. Now, put some pencils under the book and pull it again. It takes less force to move the book, and the rubber band doesn't stretch as far. The book rolls over the pencils, and there is less friction because the pencils turn. Wheels work in the same way as the pencils do. They turn on a post called an axle and reduce the amount of force that is necessary to move things. Wheels and axles help us get from one place to another in many ways.
We rollerblade on wheels.
Drive on wheels.
Pull wagons on wheels.
Wheels also can help us turn things. This doorknob is a wheel. If you take it off, you can see the axle. When you turn the doorknob, you turn the axle. The axle turns another part of the door that makes it open. Some wheels have teeth in them. These wheels are called gears. The teeth in a gear fit with the teeth of another gear. When you turn one gear, it turns the other one. The inside of this watch has gears. Can you see the gears in this egg beater? Or this can opener? A pulley is a kind of wheel. It has a groove in it and a rope or string that fits around the groove. A pulley makes it easier to move something by changing the direction of a pull. By pulling down on a string or rope, you can pull a load up. Pulleys are useful in many situations. It would be hard to climb to the top of a flagpole to lift up a flag, but a pulley provides an easier way. Pulling down on the rope raises the flag. This clothesline also uses pulleys. The pulleys used in clotheslines and flagpoles are called fixed pulleys because they stay in one place. Often, a fixed pulley is used with another kind of pulley called a movable pulley, which moves when you pull on the rope or string. A movable pulley makes it possible to move things with less force than when using a fixed pulley by itself. This man is using a movable pulley and a fixed pulley to move a heavy piece of machinery. Levers, inclined planes, wedges, screws, wheels and axles, pulleys. These simple machines can be found all around us. Other machines are made up of combinations of these simple machines.